Alright, I'm gonna talk on this video about how to identify whether a salt solution is acidic or basic. And I think that once you catch on, it's really not that difficult, but everyone's been making it a lot harder than it really is. What you need to do, first of all, is make sure you have your strong acids and strong bases memorized. So the strong acids are hydrochloric, hydroiodic, hydrobromic, nitric, and perchloric, as well as sulfuric, but I left it off because sulfuric is a diprotic acid. So when we talk about like the anion to the strong acid, well, in this case, HSO4 with a minus charge is actually still an acid. So I kind of left it off this as we go through and talk about it. Strong bases are your hydroxides that include lithium, sodium, potassium, calcium, strontium, and barium. So the thing to remember is if it's an ion that is attached to one of your strongs, either acid or base, it is going to be neutral itself. So for instance, with the acids, all of the conjugate bases to the strong acids, so you're over here, this list, the chloride, iodide, bromide, nitrate, and your perchlorate, those are all neutral. All of those are neutral. All of these over here are also neutral. Your lithium plus, sodium plus, potassium plus, calcium, strontium, and barium 2 plus. All of those are neutral. So first and foremost, when you look at a salt, try to identify any of those first, and if those are neutral, you can just kind of cross them off and look at the other side. In general, if you see a cation, you're probably going to start off by assuming that's an acid. With an anion, you'll start off by assuming that's a base. Then, if you notice that it's one of these anions, then you can say, okay, no, it's neutral. Start off thinking the cation's acid, but then if you notice it's one of these cations, and oh no, that's neutral. So let's talk about a couple examples, right up at the top right here. Strontium chloride, this one. Well, it has strontium as the cation and chloride as the anion. Well, start with the cation, strontium. Oh, look, it's right here. So that's neutral. Chloride, oh, look, it's right there. That's neutral. So that salt would be neutral overall. This one over here, all right, this is a nice crazy one because, well, I just wanted to give you one that you would know off the top of your head. So, first of all, cation. Well, do you recognize this as being one of your neutral cations? No. So whatever it is, you know that it's an acid. A weak acid, but it's an acid. Nitrate, on the other hand, oh look, it's right here. So that's neutral. So that solution is going to be acidic. This is all you have to do. You don't have to know all of your weak acids and weak bases. You just have to know the strongest. Over here, well, cation, yep, sodium's there, it's neutral. This right here, well, it's not any of those, so this must be a base because it's an anion. All right, over here with the aluminum bromide. Aluminum, well, is it on your list? No, it's not. So it's not a neutral cation. Well, if it's a cation, think acid. Bromide, well, bromide's right here, so that's neutral. So that means this one's acidic. The last one, your cation is ammonium. Do you see ammonium here? Nope, so that's an acid. Fluoride, do you see fluoride over here? No. So in this case, we have both an acid and a base working together. So how do we determine whether the solution will be acidic, basic, or neutral? Well, you have to look at their K values. So take ammonium by itself, and you find the Ka value for ammonium. It is the conjugate acid of ammonia. So the Kb for NH3 is equal to, I believe it's 1.76 times 10 to the negative fifth. So to solve for the Ka, of ammonium, you would divide 1 times 10 to the negative 14th by that, and you'll get 5.68 times 10 to the negative 10th. So this right here is the strength of this acid. So now I got to look at fluoride. Well, that comes as that is the conjugate base of the weak acid hydrofluoric acid. So the Ka value of hydrofluoric acid, if you look that up, you'll find it equal to 3.5 times 10 to the negative 4th. So if you do 1 times 10 to the negative 14th divided by that, you'll get the Kb value of fluoride, and you'll find that to be 2.9 times 10 to the negative 11th. So that is the Kb value for this. So now what you want to do is figure out which one's better at doing their own job. So ammonium is an acid. It's got a Ka value of 5.68 times 10 to the negative 10th. Fluoride is a base, 2.9 times 10 to the negative 11th. Well, in this case, the Ka value is greater than the Kb value. Ka of ammonium is greater than the Kb of fluoride, which means ammonium is better at doing its job. Therefore, it's going to be an acidic solution. Anyways, I hope that makes it easier. Seriously, don't try to memorize all of your weak acids or weak bases. Just use the strong acids to figure everything out.